Hello, good morning students. Today we have to discuss one of the safety device, that is fuse wire. Later on we come to know types of fuse wires. Later on advanced versions of fuse is MCB. We have to see that. Each electrical distribution network is started from fuse wire. Already we are knowing where we are taking the supply through the service wires. We are receiving AC power from pole to the house. Once it comes to the house, then it is given to energy meter. After the energy meter, we are getting first point, main fuse or main MCB. Already you are knowing. Now at this advanced situation, in place of fuse we are using MCB, that is main MCB board. So what is the function of fuse wire? So already I expressed, each electrical distribution network starts in the house from fuse wire. What is the power we are taking from pole to house? First it comes to energy meter, next it goes to the fuse wire, that is called main fuse wire, later on sub fuse wires or sub electric circuits. So what is the function of fuse? Fuse is a conducting material. Either it is made of copper or aluminum or lead or tin, different types of alloys. So it is basically a conductor material which is connected in series part of the circuit. It is always connected in series part of the circuit. As you can see there is a one phase, one neutral. It is of the single phase AC distribution. Always fuse is connected in series part of the electrical network. So it makes the circuit or it breaks the circuit. Hence whenever normal current flows, the fuse operation is not possible. Whenever the current exceeds more than its specified, that is during situation abnormal or fault current or short circuit current. So whenever current exceeds more than its specified value, then fuse wire starts melting. Fuse wire temperature increases because due to the heat developed inside the fuse wire is due to load current and resistance of the fuse material, that is called I square R effect. I is the current flowing, R is the resistance of the fuse wire. It is known as copper loss. So more I square R, more heating can be developed. Hence heat developed inside the material. This heating goes on, increases towards the melting point. Finally fuse blows out. Hence it cuts off the electrical supply from the electrical equipment to the main supply. Hence it is also known as a protective device. It protects the electrical equipment from the main supply for further dangerous. As shown in figure, you see there motor is connected to the single phase supply. If motor carries 10 ampere, the fuse allows 10 ampere current without melting. When the motor draws more than 10 ampere, that may be 15 ampere, you assume if motor draws 15 ampere but it is more than rated current of fuse, then fuse melts out. It protects the motor from overload condition or short circuit conditions. The fuse diameter decides the rating of fuse wire. I equal to kd to the power of 1 by 3, where d is the diameter. Hence rated current of fuse depends upon diameter of fuse. When the load current flows more than its rated, that means short circuit or overload condition or mismatched load or improper operation or improper connection, all leads to draw more current. and it has inverse time current characteristics. Hence, the load current increases, time decreases. That is the idea here. So, proper selection of fuse wire is also another important criteria. If your house carrying 10 ampere load, then we have to select a 10 ampere fuse wire. That is the idea. If we are selecting less than 10 ampere, then if any work carries, it may blow out. That is the one cause. If we are selected too much high current, then after burning off your every equipments, but fuse doesn't goes to blown out. Hence, improper selection is very danger. Proper selection of fuse wire is also very important criteria. After the fuse wire, next comes circuit breakers. In the power system, we are investing lot of investment. Hence, for example, one transformer may cost so much crore rupees. Hence, protection is also very important in an electrical system. Hence, next circuit breakers comes after the fuse. After the circuit breaker, then relays are coming to function. Its construction is very simple. It is a round shaped wire, or it may be a ribbon shaped strip depending upon the rating. For smaller currents, that is less than 10 ampere, generally we have to use round type cross sections, circular cross sections wires. Or if the current increases more than 10 ampere, then we are using strips, metal strips. It is always connected in series part. It is always connected in series of the electrical circuit. It is also known as one of the weakest link in the electric circuit. It allows the normal current. It doesn't allow the overload current, because overload current may burn your electrical equipments. It removes the overload current, but it allows the normal current. The resistance of the element, that is winding, the resistance of the fuse wire generates heating effect due to I square R. I is the current flowing, R is the resistance. It is generally called as copper loss. I square R loss, more heating effect can be produced. More heating effect is observed when current increases more than its specified value. Advantages: it is one of the most simplest protective device in electric circuit. It is not required any maintenance, that is zero maintenance. Operation of fuse is simple, and one main disadvantage, after the each operation we have to connect another fuse wire, hence more interruption of the electric circuit. The operation of fuse wire is very simple process, but has less reliability. It has less reliability, thus it is used where less reliability is possible, but it cannot be used in more sophisticated protective systems. For most protective systems, we are using circuit breakers. Lastly, higher reliability cases, then circuit breakers along with relays. Different type of relays are available. These relays are used for higher reliability. Fuse is used for lower reliability, where such that low reliability application is required. In such case, fuse is more useful.